Okay, so we are going to continue talking today about some of that financial terminology and that language of finance that we were talking about yesterday, and show you some of the basic calculations. Again, if you missed that first part, my intention is not at all to teach you math and for you to memorize all these formulas, but I'm going to use the formulas to illustrate to you some basic financial concepts that will really help you in your financial planning in your life. So to continue on, let's suppose you want to determine what an investment will be worth at some point in the future. What will the value of my investment be in N years if my interest rate is I%, for example? So say, for example, you know that you want to have $1 million in your retirement account. Well, how much would you have to put into the account at what interest over what period of time before you would have that amount? That might inform you as to when you can actually retire. So you will need to know how many years it will be until you have the investment, the interest rate, and the amount of the investment, or what we call the present value of the investment. The result of the equation will be a dollar amount that is larger than the original investment. Hopefully, you haven't lost money on the deal, since your money will earn interest, and the interest will earn interest on that interest, what Albert Einstein described as the most powerful force in the universe, compounding interest. So for an approximation, you should remember the rule of 72. And this is a great financial rule. The rule 72 states that an investment will double approximately each time you multiply the number of years of investment by the interest rate in percentage terms and get a number that is greater than 72. For example, if your investment is earning 8% interest, it will take 9 years for it to double. 8 times 9 is 72. So that's a very simple mathematical way of trying to gauge how much money will I make into the future. It's not precise, but you'll be within a few dollars most of the time. So how do we calculate this future value? Well, the future value equation is as follows. Future value equals present value multiplied by 1 plus the interest rate to the nth power. So in this equation, n equals the number of periods of compounding, years in this case, if it's an APR, annual percentage rate. The key input in the future value equation is follows. FV is the future value of the investment at the end of n periods, years. N is the number of years in the future. Although if you have compounding periods shorter than years, n would equal those compounding periods as well. I is the interest rate, or the annual interest or discount rate. PV is the present value in today's dollars of the sum of money that you've already invested or plan to invest, and you want to know what it will be worth in the future if it earns interest. So let's take a look at two similar problems here to understand this. A, calculate the future value in 15 years of $5,000 that is earning 10%, assuming an annual compounding period. So to solve this problem, we're going to have to consider compound interest. So the problem should be written as such. FV equals $5,000, the present value, times 1.10, the interest rate plus 1, to the 15th power. Or future value equals 5,500 to the 15th power, or in the end, future value equals $20,886.24. In 15 years at 10% interest, our $5,000 would become $20,886.24. So how much interest, or how much did interest on interest earn in the first problem? Well, if we take the $20,886.24 and subtract the original principal of $5,000, we'll see that we earn $15,886.24 in interest alone on this. Now, think about this for a second. Let's say you want to buy a nice car. That car is going to cost you, $20,000. You only have $5,000 today. You could, if you blow that $5,000 on other things that maybe aren't as important to you as having that decent car, and you put it away and then pick at it over time instead of letting it sit there, well, now you have to pay the whole $20,000 out of pocket. Whereas if you're just patient, delayed gratification, and you let it sit there, now you have the $15,886.24 in interest. You're letting your money work for you. You're not working for your money. And again, this is the secret to being wealthy. This is all there is to it. Let your money work for you. Now, that means you have to be patient. That means you have to delay gratification, that you can't just spend your money wildly. You have to let it sit there, and it's tempting. It's sitting there, man. I could go with Vegas to with my friends this week, and they're all going to have a blast. But the only money I got is the one I have for this goal. So you have to be kind of disciplined about your goals too. And you can see this also in problem B here. Calculate the future value of $5,000 after 15 years that is earning 10%, assuming simple interest. In other words, the interest earned does not earn interest. The problem should be written as such. Future value equals present value times 0.1 times 15 plus the present value. Or 5,000 times 0.1 times 15 plus 5,000. Or, continuing to simplify, 500 times 15 plus 5,000, or 7,500 plus 5,000, or the future value here is $12,500. Now, remember when I said Albert Einstein said compound interest was the most powerful force in the universe? Look at the difference between the $15,886.24 we got from compounding our interest, where our interest earns interest, compared to the $12,500 where it's only our principal that's earning interest. The difference between $20,886 and $12,500 is $8,386, which is the amount of interest your interest has earned. And this concept is the key to financial success. Earn interest on your interest. Rather famous financial analyst L. Tom Perry repeated what someone told him about interest when he first got into the business, when he said, "Them's that understand it earns it, and them's that don't pays it." In other words, when you go to buy that $20,000 car and you haven't let your interest earn interest, you're actually paying $20,000 as opposed to only $5,000 and letting the rest of your account earn that. And if you only have simple interest instead of compound interest, then you're paying $8,000 more still for the car. So let's earn interest rather than pay interest is hopefully what this is demonstrated to you. So now that we've kind of talked about, I don't want to say the problem, that's the first, because it's a mathematical problem, but once we've illustrated how compound interest works for you and can make your life better, why do we even want to earn interest? Why can't I just put the money in today? I mean, apart from it's kind of free money, but why can't I just put the money in today, take it out in 20 years and have it and know it's safe? And the key reason is inflation. Inflation is an increase in the volume of available money in the economy in relation to the volume of available goods and services. Inflation results in a continual rise in the price of various goods and services. And think of it this way, especially with this COVID-19 pandemic and all of us being quarantined and the government now printing out money and shoving it out to people so they can live. There's an inherent problem with that. And I've heard it from actually real people here in Marshall who've discussed this with me. I'm laid off work, but thankfully when I'm getting an unemployment plus the $600, it's more than what I would actually get at work. And that's what the government's giving right now. They're giving unemployment, which is typically only about 50 to 60% of your last salary, plus $600. Well, that $600 is taking them above 100% of their last salary. And so they're happy. But now when it comes time to go back to work, where's the incentive? I might as well not go back to work. Right now, I might as well not go find a second job or an essential job in order to make a living, because I'm making more sitting here on my butt. And so if I run a business and I need employees, I'm going to have to offer them more money to come back to work. Now, when I offer them more money, that doesn't come out of my pocket. That means my costs to make that product or provide that service go up. And that means I have to raise the price of that item to cover those costs. That's inflation in a nutshell. So in other words, because of increased inflation, your money can buy fewer goods and services today than it could have bought in the past. The best example for me is gas. When I was your age, gasoline was about 75 cents a gallon. I know that I rode brontosauruses to school. That's how old I was. But look at it now. It's about $1.56 in West T I saw the other day. That's still a 100% increase. That means if a dollar in my day, if I'd bought $5 of gas, I could have got over 7 gallons of gas when I was your age. Today, that $5 would only get me about 3 gallons of gas. So that's the difference. That's inflation. Inflation negatively impacts your investments because if you just put that $20,000 away for that car today with no interest, then in 5 years at an interest rate of 1%, now that car is $25,000. Well, your $20,000 buys less of a car now. So although the amount you are saving now will be the same amount in the future, you will not be able to buy as much with that money in the future. In other words, the purchasing power of your money erodes because of inflation. Inflation makes it necessary to save more because your dollars will be worth less in the future. In other words, all that compound interest we just made for that $20,000 car, it isn't enough if the interest rate isn't beating inflation, because that's only going to, keep our money up with the current spending rate. So let's look at our first problem here. 40 years ago, gum was 5 cents a pack. Today, it's 35 cents a pack. Assume that the increase in the price of gum is totally related to inflation and not other factors. At what rate has inflation increased over the last 40 years? And we'd input the following information to solve this problem. You'll notice here, I, the capital I here, is inflation equals future value divided by present value to the power of 1 divided by the nth minus 1. So our present value is 5 cents, 0.05. Our future value, 35 cents, 0.35. N is 40, the 40 years. And we don't know I yet. We're going to solve for that. So on average, if we figure out this problem, we get 0.35 divided by 0.05 to the power of 1 divided by 40 minus 1. And the answer is 4.99. On average, inflation has risen by 4.99% each year for the last 40 years. So the average price of gum has increased by 4.99% each year for the last 40 years, which means if I wanted to invest my money so that I could buy gum in 40 years, at what rate should my investment grow minimum? Well, the correct answer is 4.99%. That's my investment has to grow at 4.99% at least, just to have the same amount of money, the same purchasing power in 40 years that I have today. Otherwise, I've lost money. I'm actually poorer as a result. Let's look at problem 2 of inflation here, the future value of a wedding. A friend has 6 wonderful daughters, 1 wonderful son. And it's estimated that an average wedding costs $23,000. Now, assuming 4% inflation, what would it cost him to pay for all 6 of his daughters' weddings in 15 years? I hope this won't happen to him, at least not all in the same year. If we input the following information to solve for the cost of a single wedding in 15 years, we know the present value of a wedding is $23,000, assuming that on average a wedding still costs $23,000. N equals 15. That's when his daughters will be getting married roughly in about 15 years. And so the cost will increase every year for those 15 years. I is 0.04. The inflation rate is 4%. So we're not solving for I this time. We're actually solving for the future value. How much does he need in 15 years for each of his daughters' weddings? So we look at 23,000 times 1 plus 0.04 to the 15th, and we get $41,422. In 15 years, the value of a single wedding will be $41,422. That's how much he needs for each of his 6 daughters. And that means it'll cost $248,532. In other words, to see his 6 daughters married off properly and formally, he's going to need about $250,000 in 15 years. Inflation will raise my friend's costs by 80%. 422 divided by 2,300 minus 1, or the future value divided by the present value minus 1. So guess what? He needs to plan now. And it's no different than, I use a wedding as kind of a fun example, but it's no different than if you want your kids to go to college in 18 years. You plan now so that you can earn the interest to keep up with inflation. You might look at it and go, I want something in 10 years. It only costs $5,000. I'll just put $5,000 in the bank and set it aside. Except that purchasing power, that $5,000 is going to erode to the point your $5,000 might only buy 10% of it now. So you need to have investments that beat inflation, that keep you up there. Paul just graduated from college and landed a real job, his first career real job. Before, he worked fast food places, worked as a temporary worker in a factory, but those weren't his real jobs because they weren't his career, what he planned on doing the rest of his life. He gets paid $23,000 per year. Now, what nominal rate of return will Paul need to earn in the future to maintain a 2% real return rate, assuming that inflation averages 1.96% per year, which has been about the CPI average for the Consumer Price Index average for the past 50, 60 years, has been about 2% inflation. So if we use the formula, the real rate of return, RR, plus 1, multiplied by 1 plus inflation minus 1 equals n, we should be able to solve this problem. Now, the formula is only calculating for the real rate of return and solving for n, so the solution should look like this. 1 plus 0.02, the real return of 2% plus 1, multiplied by 1 plus 0.0196%, 1 plus the inflationary rate, minus 1 equals n. So we get 1.02 multiplied by 1.0196 minus 1 equals n. 1.04 minus 1 equals n. 0.04 equals n. In other words, to maintain a real return of 2%. In other words, he wants to see his salary grow by 2% every year during his time working throughout his career. Paul will need to make a nominal return of 4% in the future. In other words, he needs to see a 4% increase in his salary every year to actually see a 2% increase. So in nominal terms, what will Paul's salary be in 10 years if he only gets that nominal return? Now, assume that his salary keeps up with inflation and assume inflation averages the same 1.96% per year. And to solve this, we're going to use the formula for calculating the future value. Future value equals present value multiplied by the inflationary rate plus 1 to the power of the number of periods. So the future value in this case equals 23,000 multiplied by 0.0196, the inflationary rate, plus 1 to the 10th, if we want to know what his salary will be in 10 years. And to maintain his current purchasing power 10 years from now, Paul will have to make $27,927.12 in real terms. Now, he started out his job $23,000. And 10 years later, now he's making $27,927, close to $28,000. Has he done good in his career in terms of money? And the answer is no. He hasn't done anything. He's made no progress because his salary is only kept up with inflation, meaning that he can only buy now what he could have bought 10 years earlier. That's it. He can't buy any more. He can't live a better life. And this is why it's very important to understand inflation and everything in terms of judging your career is, okay, am I making progress? Should I look for somewhere else to work in these regards? An annuity is a series of equal payments that a financial institution makes to an investor. And we talked about what annuities were in Unit 2 even, but certainly at the beginning of this one, I laid out these definitions. These payments are made at the end of each period, usually a month or a year for a specific number of years. Let's say, for example, you're in a horrendous car crash. You're injured, you can no longer work, you win a lawsuit for $10 million to cover your expenses. They don't write you a check for $10 million. What they do is they annuitize that amount. They put that $10 million in a bank and they divide that and the compound interest earned from it by a certain specific time period, and they pay you that $10 million. It's a way for, think of it as this way, the company that has to pay you or the person that has to pay you actually is saving money on it because they're letting the compound interest detract from that $10 million to pay you. So by the end of it, if it's like a 30-year thing, they may have only had to pay you $6 million instead of $10 million. So to set up an annuity, and annuities are usually normally what you do with your retirement. You've saved all this money, you annuitize it. You go to Prudential or someone like that, Mass Mutual, Pacific Life, and you buy an annuity. And then they divide that annuity up. This is what actuaries do. They have these actuary tables about your expected lifespan based on your personality, your risks, things like that. And let's say you're expected to live another 25 years after retirement. So most people retire at 65. That'd be, let's say you're expected to live to age 90. They divide up how much you're putting in there over the expected interest rate, how much compound interest they'll earn, and then they pay you a certain amount every month. That's your retirement check. And again, they're making some money on this because they've taken into account the compounding interest and that, and of course it extends your retirement too. They're not taking all the compounding interest. If you only had $10 million in the bank and you were expected to live 25 more years and your average needs were $1 million a year, what would you do for the extra 15? Well, luckily the interest most likely will cover that. And I know those are big numbers, who needs to live on $1 million a year, but it just gave me a round number to demonstrate and illustrate this. So to set up an annuity, an investor in a financial institution, for example, an insurance company, sign a contract in which the investor agrees to transfer a specific amount of money to the financial institution, and the financial institution in turn agrees to pay the investor a set amount of money at the end of each period for a specific number of years. Now, to determine the set amount of each equal payment for a certain investment, you have to know the amount of the investment, the present value, the interest rate, I, and the number of years the annuity will last, N. So let's look at problem 4 here, annuities. When you retire at age 60, you have $750,000 in your retirement fund. The financial institution you have invested your money with will pay you an interest rate of 7%. Now, assuming you live to age 90, you will need to receive payments for 30 years after you retire. How much can you expect to receive each year for your $750,000 investment with a 7% interest rate? And the formula for solving this is as follows. The present value, or the payment, equals the rate of return times the present value divided by 1 minus 1 plus the rate of return to the negative n. The n again representing the number of years. So to solve this problem, we'll set $750,000 as our present value, PV. We'll set 30 as the number of years, N, and don't forget the negative sign there, so it's actually going to be negative 30. Set 7% as your interest rate, R, 0.07. Remember to convert it to the percentage rate to a decimal. And now solve for the payment, P. And the future value of this annuity, when we plug all these numbers in, is $60,439.80. And this means that you should receive 30 annual payments of $60,439.80. Now, if you're accustomed to living on a salary of $80,000 a year and you don't want to change or reduce your lifestyle, $60,439.80 isn't going to cut it. So by doing this formula, you would know I have to increase what I'm putting in my retirement account. A compound annuity is a little bit different. That was just a simple annuity. A compound annuity is a type of investment in which you deposit a set sum of money into an investment vehicle at the end of each year. You should deposit this amount for a specific number of years and allow that money to grow. Now, suppose you're looking to buy a new four-wheeler to remove snow from your driveway. Instead of borrowing the $7,500 you would need to pay for the four-wheeler, you want to save for the purchase. So you need to ask yourself two questions. How much will you need to save each month if you want to buy the four-wheeler in 50 months and you can earn 7% interest on your investment? And how much will you need to have to save each month if you want to buy the four-wheeler in 24 months and you can earn 7% interest on your investment? How long are you willing to wait? And the formula for solving this is as follows, and this is a triple layer division formula, so bear with me. Again, you don't have to memorize or work these out. You just have to see kind of what goes into them. Future value divided by 1 plus 1 over the interest rate to the nth minus 1 divided by the interest, or the inflationary rate divided by the interest rate. So to solve the first question, input the following information. The future value equals $7,000. N equals 4. The interest rate is 7. Payment, we don't know. So if you earn 7% interest on your investment, you'll need to save $120.98 each month to save $7,000 in 50 months. To solve the second question, input the following information. 7,000 is the future value, N equals 2, I equals 7. The payment is what we're solving for. And after solving for the payment, you'll discover that you need to save $272.57 each month to save $7,000 in 24 months. So if you're willing to wait 2 years to get it, there's a significant savings here over the, if you want to wait, if you want to get it in 2 years, you're going to spend a lot more money, notice, than if you waited 5 years here, or close to 5 years, by about $100 a month that you won't have to pay for it. So as a general rule, you can see the savings. You can see that also, if you borrowed the money, you would be paying the interest to someone else on the money you borrowed. That four-wheeler would cost you a lot more. If you're patient and you invest the money, then you're earning the interest, and that reduces the cost that you'd have to pay for this. So being patient and saving your money pays off. The rich don't pay the same amount as the poor who engage in using a lot of credit. If you engage in using credit, you're paying more. I'll give you a great example. There's this really sweet recliner that I saw at Big Lots. I'd really love to have it. It's $400. Well, I don't have $400 quite, just for a fun purchase like that. So I figure if I save it, I might be able to get it by July. And that's, in 4 months. Now, Big Lots has this borrowing program they're really pushing, and I looked at it. If I borrowed the money with the interest rate and the fees they charge, that chair would come out to be $900, but I'd have it now. Well, is the chair that important to have right now? It's nice, it'd be comfortable, probably help my back a little, but it's not medically necessary that I have it right now. So rather than paying for 2 chairs at the $900 and borrowing the money, which a lot of people will get sucked into because Big Lots is only $1 down. Things like, your cars today, you watch those commercials, and they're going, we've deferred the first 3 months payment. Notice they didn't say you don't have to pay the first 3 months, that they're going to knock it off the bill. They deferred it, which means what? Hey, guess what? You have to pay those first 3 months on the 4th month, plus the interest it earned. They're actually still making money on you. Whereas if you're patient, you have the money, and you just pay for it yourself, you're knocking a ton off the rate there. They're not making any money off the interest. You're not having to pay interest and pay more, like on that chair. I could buy 2.5 chairs with cash than it would take me to borrow that money for the chair. That's what I'm trying to say. When you go up to these title places and places like this, and you get a loan on your car from your title, it's great to have that money. But look at what you're paying. They charge over 300% on those things. This is, most of the U.S. economy, believe it or not, is made off making money off poor, uneducated people in finance. And that's what I'm trying to teach you today, is these financial principles that will save you tons of money in the future. But in order to do that, you not only have to understand the principles, you have to be disciplined. You have to understand delayed self-gratification, that sometimes it's better to wait a little bit for something. And you have to understand, too, the powers of inflation and interest on these things. So hopefully we've gotten you a lot of that today, and we'll start getting into investment and types of investments tomorrow to begin that. Do you guys have any questions today? Okay, well, if you don't have any questions, then thanks for coming, and we'll see you tomorrow, hopefully.